So here we're going to start talking about properties of gases. So characteristics of gases, gas pressure, the definition and the units associated with gas pressure, calculating pressure, and how we go about measuring pressure. So some characteristics of a gas. It'll assume the shape of and volume of its container, which I think we're probably familiar with. We can compress gases. That's another characteristic of gases, which is not so much true for liquids or solids. And densities of gases are very, very small in comparison to liquids and solids. And they can vary quite a bit depending on other factors like temperature and pressure. Gases will become homogeneous mixtures, or these homogeneous solutions with one another in any proportion. And they will do that very quickly. So gases will mix very, very quickly in general. So they become homogeneous mixtures. So the definition of pressure, it's a classic physics definition is a force divided by an area. So force divided by an area. There's an SI unit for a force, and that is a Newton. A Newton is a kilogram meter per second squared. And the SI unit of pressure is the Pascal. It's defined as 1 Newton per square meter. So you could kind of do the math there and figure out that a Pascal is a kilogram meters times second squared for those units. Pascals are not terribly common in general for what we often will deal with. There are a bunch of other units of pressure that we may or may not be familiar with. One of those units is an atmosphere, ATM. We're roughly at 1 atmosphere at sea level. So here, where we're sitting right now, we're at roughly 1 atmosphere. And even weather patterns can change that just a little bit. But you can see 1 atmosphere is a little over 100,000 pascals. Another one would be millimeters of mercury. And 1 millimeter of mercury is roughly 133 pascals. And you can see millimeters of mercury and torr are about the same thing. And then lastly, there's bar. There's a few others that maybe you'd be familiar with, like inches of mercury, or PSI, pounds per square inch. So these are some pressures that we could interconvert between using dimensional analysis like we have in the past. So we can measure pressure as well. First, you could use a barometer. Barometer gets us barometric pressure. That's where that term comes from, which is just atmospheric pressure. So here you can see, let's say you had a liquid like mercury, for example. And you have some sort of atmospheric pressure pushing down, and then it will push that liquid up a tube a certain amount. And that is actually how you get millimeters of mercury or inches of mercury traditionally, for example. So standard atmospheric pressure is 1 atmosphere, like I had said. So that is actually equivalent to 760 millimeters of mercury. So that's the pressure that would support a column of mercury that is 760 millimeters high at 0 degrees Celsius at sea level. So that's 760 millimeters is 76 centimeters. So that's why you're seeing that in the figure. We can also measure pressures of stuff that's other than the atmospheric pressure. So a manometer will do that as well. So you can see there's a pressure associated with a gas in that closed system there. And you have a similar sort of setup where you're pushing some liquid like mercury, for example, some height up another column. And the difference in those heights, the bigger the distance, the higher that pressure for that gas in that container. So you can measure other pressures essentially.